are talking about 61850. It's an open protocol. If I construct a 400 kV substation, I will spend about 500 crores of rupees for a substation. And for getting it to automated, it is taking more than 3 months time for a supplier to commission it. Coming itself, the persons coming for coming itself, it's taking more than a month or 2 months, and every project is getting delayed by 4-5 months. What is the interest cost that we are investing on our IDC for automizing the substation? It must be a plug-in, and if it is a open protocol, you must be in a position to just plug in. You must do everything in the factory. You have to take the concept of a substation and how many feeders are there, everything has to be done it in a factory. If it is ordered for a substation, and it must just come get it here and just commission it. For commissioning the automation system, the people are not experts. The people who are coming with the OEMs are not experts. Very, very, very fresh people they are sending, and they are able to commission the substation. Digital substations, we are talking about 5-6 years, last 5-6 years. I don't think there is a successful digital substation in the country as of
now. So we'll come to this point you raised. Mr. Reddy raised an issue, actually. So, Mr. Anil, will you be able to respond on this, according to your experience?
Yep, definitely. So, I mean, this question is really very interesting, because so IEC 61850 is a framework. I mean, to be very honest, it has got a very larger framework. So when we talk about the substations, digital substations, it is actually a technology. It starts from your substation, then communication protocol, and then it goes to your control center, right? So if you talk about retrofitting, like, because the conventional control centers where we have got RTU, and then we have got lot many copper wires here and there, and then we are getting those hardwired signals and all those things, and then we are getting that communication. That was the way how it has happened for the substations. But when we talk about IEC 61850, actually it's a transformation, and definitely what sir said, it is very important, because the learning curve is not that easy for IEC 61850. It actually requires expertise, to be very honest. So if we have got that expertise in the team, it can be built. And because the product itself, like when we talk about the communication, that link, like in terms of, like, if I talk about the conventional way of doing it, so we have got RTU on IEC 101, 104, which are the traditional communication protocols, and we have got hardwired signals, and we just do it. And I mean, then the substations are designed in that way. But when we talk about IEC 61850, we have to install IEDs first of all. Then we have to, so in terms of when we are thinking of retrofitting and other stuff, I don't know like how those kind of will work. But we are talking about when we are thinking of building a new substation, right? Then if we start taking care of all those things, then it becomes easy, rather than doing that upgrade or retrofitting kind of scenarios. And absolutely, I echo that word. Like, if you do not have expertise, if you do not have proper training to the people, if we do not have those experts running on the ground, it will not happen, because this is something which is totally new. And I already said, as per CA only, or as per ISGF report I was reading, only 15 to 20% of the substations have got this IEC 61850. And like, we have to also see like what stage they are, right? I mean, report can say, okay, it has been implemented, but how it is working is the another question which we need to see. So this is my answer to that question. I mean, it needs expertise first. It needs right system integrator, right technology provider with whom we have to plan these things beforehand. And definitely the timeline. I mean, the timelines will vary based on the as is your current state, how your current state is.
Sir, I have a continued question.
Yep.
See, the problem is with the manufacturer. There are only 5 or 6 manufacturers who do the automation systems in the, and all 220 kV and important 130 kV and 400 kV substations. As Telangana state, we are going ahead with the automation system. But Having spent crores of rupees, we are waiting for months together to commission those substations. None of the manufacturers, let me tell you very frankly, none of the manufacturers have expertise. There are only one or two expertise people in the country, each manufacturer. And many of the people who are coming there for commissioning, let it be very frankly, we shall have a very frank discussion. And they are the temporary employees. They are deputing temporary employees. They are not even permanent employees of the company. See, how shall we go? We should insist when we are talking about the technology, either the CEA or anybody shall insist that these people shall have expertise, minimum number of expertise people according to their manufacturing capacity. And let me tell you this retrofitting, it is worst case retrofitting. This has to be solved, sir. This has to be solved by the people who are at the helm of affairs, making policies for digital substations, 61850 substations and all other things. See, after all, a substation stands for about 40 or 50 years, and this automation system stands for only 7-8 years. And what is the, if you want to upgrade a substation, means with a new software or new automation system, how much downtime of a substation it comes to, sir? How much downtime we have to face this? See, all of them are becoming non-conventional substations. We have been adopting this for the last 15 years, I think 12, 13 years we have been adopting, but the first substations, many of the substations doesn't have, those manufacturers are not there in the country. They cannot update. We have to buy a new automation system. How many days, how many months we have to keep the substation off? Will it be possible for anybody to keep the substation off and run the system? All these things has to be thought over, sir. All these things has to be thought over. And when I if I buy one company automation system, if I buy another panel of that company, I must be in a position to just plug in. If it is a real open protocol system, even if it is other company also, I must be in a position to just plug in. Why this is not being insisted? These are all the operational problems that are coming to with the technologies, See, all these, when we promote the technology, all these things have to be answered. There must be an answer, and we must be in a position to implement it, sir. Thank you.
I think this is a very interesting thing what Mr. Reddy just spoke of. And I think he is very true to this. And he has presented the facts the utilities are facing. So moving ahead with these problems which we face and utilities face, Mr. Harshal, will you be able to please explain what Sir just told about how we can overcome these problems are already there on the floor. What steps should be taken to overcome these problems?
Yeah. No, I completely resonate with the thoughts of Mr. Reddy because we being an EPC company, we are somewhere in between the customers on one side and the manufacturers on the other side. So these are typical problems that we also face, right? A major issue in this whole ecosystem has been that the intent has been good behind putting the standards, behind the CES, the overall plan. The intent has been good, but we haven't been able to scale up manufacturing to meet that intent. And even in smaller things like lattice tower structures or monopoles or conductors, we see that we haven't been able to scale up manufacturing. And what has occurred in the country is that there is a dominance of 2 or 3 global players or local players that play in a specific sector. Now, what that does is that first of all refrains from new manufacturing to come up, and secondly, if you are not skilling at the level that the technology is growing at, then you are left with nothing but foreign skill to come in, and foreign skill is expensive. Have engineer from GE or Siemens America come and install those systems is quite expensive, as any state utility or PGCIL will tell you. So there's multi-pronged problems here. One is the manufacturing issue, as I said. The second is a skilling issue. And thirdly, as he rightly said, it's a system integration issue at the end of the day. So even I used to work in oil and gas. I was a system integrator. The typical tendency is to have third-party system integrators who can communicate, who you can rely on to communicate between different systems. But that doesn't help when the OEM's material is in place. You need people from the OEM and that expertise from the OEM to come in and help. And this is typical OEM sort of way of working, where the upgrades have to be there every 4 or 5 years because they are a source of revenue for them. Microsoft, for example, will ask you to update Word or PowerPoint every 3 or 4 years, and that's how they generate their revenue. But I feel there should be long-term plans in place, even from the OEM side, that ease the burden on utilities to get this all implemented and done.
You see, discoms are generally at the receiving end. So whatever comes, discom have to adopt it. One thing is the customer, because we are the customer facing. So for customers reliability enhancement, we have to adopt the solution. On other hand, we have regulator who are very conservative in kind of passing those requirement of capex and upgradation, mainly the replacements. So the discom is kind of sandwiched. At the same time, discom is very innovative, finding out solution in these constrained situations. So retrofitting comes like very handy for the discoms in a way that with a little cost, with little additional cost, without replacing the existing equipment, if you can deliver the or expected results, may not be like in sustainable way, like we designed equipment or anything for 25 years. Retrofitting may not work for that long, but at least it comes for some solutions. For example, if you see, we have a lot of switch gear, like in our system we have about 15,000 rmus. So replacing those conventional rmus with the frtus or motorized rmus to implement the dms adms solutions, that requires a lot of capex. So what we are trying to do is we are trying to have the communicable fpi on the existing RMU to at least sense where the exactly pinpointing the fault, so that our restoration is faster. We can pinpoint the fault, we go to the site, isolate, and then source it from the or put the supply from the other end. So though discoms are constrained, at the same time discoms try to find out solutions which is available, if possible retrofitting the existing one, or at least adopting the new solutions for the new equipments. This is the generally approach for the discom.
So where is the future? If we talk about where is the future? So Mr. Harshal, would you like to answer this?
No, I think, as I said in my presentation also, right, the growth is imminent. And with scale, monitoring becomes that much difficult if you are still on manual mode. So you have to go to automated modes as we go forward. You have to go to digital modes as we go forward. But that call needs to be made very cautiously. That call needs to be made, keeping all the things in mind. For example, if you already have a 99.9% uptime on current transmission lines, now does it make sense to, go ahead, tear them down, upgrade, those sorts of things? So that needs to be a very cautious call based on the capex. And I hope that the central government can support these initiatives in some or the other way, at least fund some initiatives and help the state utilities there so that they can build the infrastructure, which can then be integrated, of course, to the grid. So those are the key things I think required, and this is where the future is headed.
Yeah, I think the future is very bright. Everyone is at least started talking to modernize or think for the future. like CA has come up with the resource adequacy plan, which not only the power, but also it talks about the network. And not only network, it's like the resilient network. So I think ecosystem is thinking in right way, and we are at the cusp of time wherein everything is moving in one direction. So I am very positive about the changes being done in the ecosystem, and it will bring result for sure.
Before winding up this session, your closing statement on this. Whatever we have discussed, innovations and the future prospects.
Technology, excellent technology. GIS technology. Technology means HTLS conductors. That is the technology, automation technology means it must be like a GIS substation, conventional substation to GIS substation. How the facilities are improved. And a conductor, ACSR conductor to HTLS. How can we easily improve the capacity of the country, capacity of the line, and in turn to the capacity of the country also. And these automation technologies, means digital substation technologies, people who are manufacturing these have to at least think now and to update and facilitate the utilities to a maximum extent possible. There is a lot of future in the country. See, suppose by 2030, our network capacity has to be increased to 750 gigawatts generation. And we have to increase our capacity by another 80% of our transmission line capacity, substation capacity has to be increased in another 5 years. How we shall do unless otherwise technology evolution comes. So until the technology evolution is adopted, it is difficult to achieve, and we have to achieve. We do have to achieve by increasing the transmission capacity, transformation capacity, and generation capacity. So people who are at the helm of affairs, the MNCs, they have to think of it and do their research and improve their manpower to meet these targets.